Hello, and I want to welcome you to a video on discussing multiplying polynomials. The main topic of this will be to multiply monomials times binomials times trinomials, and then multiplying binomials times binomials, or trinomials times binomials, or any combination of the sort. First of all, we're going to be multiplying monomials times monomials, then monomials times binomials, then monomials times trinomials, so even more. So let's get started. The steps are to multiply each term of the first polynomial by each term of the second polynomial, and then combine like terms. Okay, so for this first example that we have here, 1 is 8x squared times 3x. And what we want to do is multiply the 8 and the 3 together, and then multiply the variables that go with each. So x squared went with 8, so let's place it first, times the variable that went with the 3, so that's x. So when we combine those, we get that 8 times 3 is 24. And then we just have the exponents here. So we just add. We see there's a 1 right there for the regular x power. So let's add those to have x to the third power using our rules of exponents. Okay, for example 2, we have 3a times the quantity a plus 2. And for this, we want to use the distributive property. We want to take this 3a and multiply it by everything else inside the parentheses. We want to do that by saying 3a times a plus 3a times 2. And let's go through and simplify. 3a times a is 3a squared plus 3a times 2. 3 times 2 is 6, and then we just bring the a along with it. We see there is nothing to combine because the a squared and the a cannot come together. That's as far as we can go with that example. So let's look at number 3. Let's use the distributive property to bring the x cubed across everything else inside the parentheses. So we have x to the third times quantity x plus 2. Using the distributive property, we're going to say x to the third times x plus x to the third times the 2. That's the other part left in the parentheses. So we can simplify. We're just going to be able to add these exponents together to have x to the fourth, because we said 3 plus 1 to get 4, plus the multiplication of 3x, x cubed times 2. There's a 1 right there, so 1 times 2 is 2. Bring the x cubed down. We cannot combine those because we have for the operation of addition, so we cannot combine those. That is the simplified term. Okay, now let's look at number 4. We have a 4x squared times this quantity of 1 plus 2x. So let's distribute the 4x squared to everything inside the parentheses. So 4x squared times 1 plus 4x squared times 2x. Let's go through and simplify exactly what that means. 4x squared times 1 is just 4x squared, plus, let's say 4 times 2, that gives us 8. We have x squared times x now, so we can just combine those to have x cubed. We just added those exponents. Okay, so let's finally look at example 5. This one's a bit more involved, but I think we can work through it pretty well. We have 3x squared y times the quantity 2xy plus 2x plus y plus 4y. Well, one thing I might do first is combine this right here, because that's just going to help us in the long run. We can go through and distribute anyways, but combining these might be a bit simpler. So we have 3x squared y times quantity 2xy plus 2x. Okay, and we combine those, we're going to have 5y. Now if we use that distributive property to multiply the 3x squared y times everything inside the parentheses, let's say 3x squared y times 2xy plus 3x squared y times 2x plus 3x squared y times 5y. And that's just distributing this number outside the parentheses to everything inside. Let's go through and multiply, and then we'll simplify. So 3 times 2 is 6. Let's add the exponents. So we have 3 plus 1, or excuse me, 2 plus 1 is 3. And then each y has 1, so we're going to have y squared. Over here, let's multiply to get 6. 3 and 2 give us 6. Add our exponents, so x to the third, because 2 plus 1 is 3. There's only one y, so let's just leave that y right there. And let's add. We have 3 times 5 is 15, and we only have the x squared value, so drop it down, and then each y has a power of 1, so we add those, we have y squared. If you look, we are not going to be able to simplify any further because each term has a different, no values have the same terms for the variables. The variables do not share similar exponents. So now let's look at whenever we multiply instead of a monomial times a polynomial. Let's look at whenever we multiply at least 2 binomials together. We're going to do something called special products, multiplying polynomials continued. We're going to use what's called the FOIL method. It's called first, outer, inner, last. An example, our first, we have to multiply the x times that x right there. Then we have to multiply the x times the other outer value in that second set of parentheses. That's called the outer. For the inner, we have to multiply the 7 times the first value in the second set of parentheses. That's the inner. For the last, we're just going to multiply that 7 times the last value in the second set of parentheses. If we do that, we have x times x for first plus x times 2 for outer plus 7 times x for inner, and finally 7 times 2 for last. So this is first, outer, inner, last. And it's important to remember that this can be simplified to x squared plus 2x plus 7x plus 14, which in itself can be reduced to x squared plus 9x plus 14. So let's look at number 1 now that we have an example. So number 1, let's use the FOIL method. Let's first distribute the x to everything in the parentheses, and then we'll distribute the 2 to everything in the parentheses. So to do that, we say x times 2x plus x times 1. That's going to get our first and outer part of FOIL. For the I and the L, the inner and last, we want to do plus 2 times 2x plus 2 times 1. Okay, so let's simplify. X times 2x is 2x squared, plus 1 times x is x, plus 2 times 2x is 4x plus 2. Let's go through and simplify that middle term there. So we have 2x squared plus 5x plus 2 is our final answer. Let's look at number 2. We have a trinomial times a binomial. What I would recommend doing to save a bit of time is I would swap positions of the binomial and trinomial. I would say instead of x squared plus 2x plus 1 times the quantity x plus 2, I would just swap the positions and make it x plus 2 times 2x plus, x squared plus 2x plus 1. It's going to help with using the FOIL method. So let's now take the 2 and distribute it across everything found inside the parentheses. Then we'll take the 2 and distribute across everything we see in the parentheses. As you can tell, we're using a lot of the distributive property. So let's start. I'm going to write right over here. So we're going to say that x times x squared plus x times 2x plus x times 1. Okay, and that takes care of the x for the complicated part of FOIL. Now let's work with distributing 2 across everything. I'm going to do it down here. So plus 2 times x squared plus 2 times 2x plus 2 times 1. If we go through and simplify, x times x squared is x cubed plus x times 2x gives us 2x squared plus x times 1 is x. And then over here we have 2 times x squared to give us 2x squared. Over here we have 2 times 2x, so it gives us 4x. And then finally we have 2 times 1, or just 2. Let's go through and find similar terms by grouping, and we'll combine them. So everything with x cubed will circle. I believe that's the only term we have to work with. Everything with x squared will circle. So our circle 2x squared and this other 2x squared. Everything with just a plain x, I'm going to put a squiggly line like that. So put just a plain x, and then over here by the 4x, and everything not associated with a value, we'll just, with a variable, we'll just get a plain underline. So just underline plain 2. Now through grouping, we combine the x to the third, and then everything with x squared. So 2x squared plus 2x squared gives us 4x squared. Everything with the squigglies, or just the plain x's, we'll combine next. So we have x plus 4x. Remember there's that 1 in front of the x, so we have 1 plus 4 gives us 5x. Then finally, everything that does not have a variable has that plain line, or just that 2, so just add 2. And for our last example, number 3, it looks a little strange, but we can work with it. We have the quantity 2y plus 3, all that squared. What that really means is just multiply the term by itself twice. So rewrite it as 2y plus 3 times 2y plus 3. Now we want to use the FOIL method. We'll have the 2y being multiplied by the first 2y in the second set of parentheses for the first. Then we'll have 2y times 3 in the second parentheses for outer. Then 3 times the 2y in the second set of parentheses for inner. And then 3 in the first set of parentheses times 3 in the last set of parentheses for the last. And that's going to build the FOIL. So 2y times 2y plus 2y times 3. And then again over here we have a plus 3 times 2y And finally, we're going to get the last part of FOIL with 3 times 3. Let's go through and simplify our multiplication. So 2y times 2y is 4y squared. Over here, 2y times 3 is 6y. Over here, 3 times 2y is 6y. And then finally, 3 times 3 is a positive 9. Let's simplify even further. This 6y plus 6y. We have 4y squared plus combining those gives us 12y. And then finally that 9, bring it on down. And as you can see, we cannot simplify anything because we have y squared and y's, and then we have just a plain number. So this will be our answer.